Press the bell icon on the YouTube app and never miss another update.
Next, another one beautiful concept is there. The number of elements, in exactly one set out of three given sets A, B, C. This is the concept. Okay. Here, first draw Venn diagram. Draw the Venn diagram. I will take the three sets. It is capital A set, B set, C set, capital C. Now, exactly one set means only one set, only one, or only one set, only one means this area. This is only A. This one. Next, only B means this one. Only B. Only one set. Next, this one. Only C. So, we want total this area. We are finding this shading part. Only this one. Is it visible? Right. You come here. First, this is capital A. We want only A. Only A means first delete this A intersection B area. So therefore, that is equal to N of A, in which we are subtracting N of A intersection B, means we are deleting this area, total A intersection B. Remember, we are also deleting this area. This area means what? It is A intersection C. 1 minute. So, first delete this area, A intersection B. Next, plus A intersection C. 1 minute. Delete this one. Okay, we deleted. Later, only this area is what? Only this area means A intersection C minus this area 3, A intersection B intersection C. Understand? So plus N of A intersection C minus N of A intersection B intersection C. Did you understand? Means first A intersection B we are deleting. So delete A intersection B. Later only this area. This area is what? Tell me. AC area. This area is A intersection C. But we don't want this. That's why subtract like that. So therefore, this minus this is equal to only A. Only A. Next, latter with respect to B plus n of B minus the set of similarly tell me this area. Okay, first, so B means this is say capital B. We are deleting first A intersection B, n of A intersection B plus latter we are deleting this area, BC area. This is BC area. This is A intersection B intersection C. Okay, like that. So n of B intersection C minus means only this area. That's why we have to subtract this n of A intersection B intersection C. Right. Next, similarly, plus n of C minus, now tell me about this C. C means this is capital C. We have to delete this area. This area means this area. This area means what? AC. AC. Like that. Latter, this area. This is what? BC. This is B intersection C. Similarly, n of AC, A intersection C plus n of BC, n of B intersection C minus n of A intersection B intersection C, like that. Like that. So that is equal to n of A plus n of B plus n of C minus A intersection B, A intersection B. Two A intersection B's are there. Next, B intersection C, B intersection C. Two B intersection C's are there. AC, AC. Two AC's are there. So minus 2 common, n of A intersection B plus n of B intersection C plus n of C intersection A. Next, minus into minus plus, minus into minus plus, minus into minus plus, plus 3 into n of A intersection B intersection C. Of course, it is the proof for exactly one set. Exactly one set. So therefore, this is the formula for finding the number of elements in exactly one set out of given 3 sets. This is important. Next, over. So therefore this area means this shaded part. This shaded part, like that. Like that. Okay. Next, the number of elements in exactly 2 sets. So this is say Roman number 1. Next, Roman number 2. The number of elements in exactly 2 sets. Exactly 2 sets. Out of A comma B comma C. Out of A comma B comma C. Okay. Let us take the Venn diagram. This is the Venn diagram. Venn diagram. Universal set. This is mu. This is mu. Next, ABC. ABC. A, capital A, B. This is capital B. This one is capital C. 3 sets are there. Now we want exactly 2. Exactly 2 means I will shade the required part or required area. exactly to, that's all, exactly to, that's all, exactly to, that's all. This is our required area. This is our required area. Understand? Right. Now that is equal to here first we will take this area, means this area. It is what? N of A intersection B, A intersection B. But we don't want this part. It is what? A intersection B intersection C. So subtract this area. Minus N of A intersection B intersection C. Next, plus this area means BC area. BC. This is B intersection C. This is B intersection C. So therefore, N of B intersection C. But we don't want this area, means this area. So BC. This is BC. Understand? We don't want this area. Therefore, we are deleting this area. So it is only B intersection C. So minus N of A intersection B intersection C. Next, plus N of, like that, AC. N of A intersection C minus N of A intersection B intersection C. So that is equal to, on simplification, N of A intersection B plus N of B intersection C plus N of C intersection A minus A intersection B intersection C. 1, 2, 3 minus 3 into N of A intersection B intersection C. So this is for exactly two sets. So therefore this is which gives total number of elements in exactly 2 sets out of given 3 sets. Okay. Next, number 3, number of elements in exactly 3 sets. Roman number 3. Exactly 3 sets. 3 sets. Exactly 3 sets means N of A intersection B intersection C. A intersection B intersection C. Okay. Next, another heading. At least note out of 3 sets, number 1, at least exactly it is over, at least one set out of given sets capital A comma capital B comma capital C is what? At least one set means N of A union B union C. Already I said in the synopsis or basics. At least one out of 3 means N of A union B union C. Out of 2, at least one means N of A union B. At least means union. That's all. Next, number two. At least two sets. At least two sets out of three means n of A intersection B plus n of B intersection C plus n of C intersection A minus 2 into n of A intersection B intersection C. Over. Later we discuss its application. For doing the application, let us consider once again exactly here. Exactly two sets. Okay. Next, note. We know that n of A union B union C is equal to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of C intersection A plus n of A intersection B intersection C. This is the standard formula. Okay. So from this equation, let us take or express the value A intersection B, n of A intersection B, n of B intersection C, n of C intersection A as a subject. Means take this value in left hand side, then it becomes n of A intersection B plus n of B intersection C plus n of C intersection A is equal to n of A plus n of B plus n of C plus n of A intersection B intersection C minus n of A union B union C. 1 minute, you come here. Let it be Roman number 2. This is Roman number 2. Therefore, Roman number 2 follows that you look here. N of A intersection B plus n of B intersection C plus n of C intersection A can be had n of A plus n of B plus n of C plus n of A intersection B intersection C minus n of A union B union C. Next is what? Minus 3 into n of A intersection B intersection C. So therefore, on simplification, n of A plus n of B plus n of C, latter n of A intersection B intersection C minus 3 means minus 2 into n of A intersection B intersection C. Next, minus n of A union B union C. So therefore, Roman number 2 is what? About exactly two sets. So therefore, this is also a formula for exactly two sets. For exactly two sets. Understand? Okay. Later we shall take the application. Its application. Let us take one question. In a class of 55 students, the number of students studying different subjects are 23 in mathematics and 24 in physics. Means 23 in mathematics means n of m equal to 23. 24 in physics, n of p is equal to 24. Next, n of c equal to 19. Next, n of m intersection p is equal to 12. And n of m intersection c is 9. Next, n of P intersection C is 7 and 4 in all three subjects, means 4 is equal to n of M intersection P intersection C. I wrote the same here, given that you must write like that, and if possible, by reading the question, you can draw this Venn diagram according to the given values or given conditions. You draw like that. Already I said first we have to fill the intersection of three sets, M intersection P intersection C, like that. Okay, first fill this part. Later PC. PC means this area. This area. PC means this area. This area. So PC 7. Already 4 is filled. So remaining I wrote 3. Just like that. Similarly, you fill all the areas. Okay. First method. Venn diagram method. What is the question? The number of students who have taken exactly one subject. Therefore, exactly one subject. Exactly one subject means it is 6. 6 plus 9, this area 9. Next 7, that is equal to 7. So therefore this is exactly one area, one set area. So 9, 7, 16, 22, total 22. Hence the problem. This is the first method. Second method, formula. Second method. You come here. Exactly one subject means you come here. Exactly one means this formula. N of A plus N of B plus N of C means here N of M plus N of P plus N of C. Next minus 2 into N of M intersection P plus N of P intersection C plus N of C intersection M. Next plus 3 into N of M intersection P intersection C, that is equal to how much N of M? 23 plus N of P 24 N of C 19 minus 2 into intersection MP 12 PC 7 CM means 9. Next plus 3 into 4. So therefore you can calculate this, it is 22. We are obtaining same answer. So therefore for exactly 2 set or for exactly 1 set, you can follow either formula or Venn diagram. My best suggestion is just you follow the Venn diagram, because in this Venn diagram we can find exactly one set. Exactly one set means only M, only P, only C. Next we can find exactly 2 also. Exactly 2 means this one, like that. 8 plus 3 plus 5, like that. It is exactly 2 sets. Okay. Next exactly 3 sets means N of A intersection B intersection C means just it is 4. Okay. At least one set means N of A union B union C. N of A union B, of course it is 55. 6 plus 8 plus 9 plus 4 plus 5 plus 3 plus 7, just like that. Okay. Next exactly 2 sets, at least 2 sets means we can follow this formula. Okay. So therefore 2 methods are there, namely number 1 formula, number 2 Venn diagram. Hence the problem. In a class of 140 students, numbered from 1 to 140, means what? 140 students are there. For first student, they numbered means assigned the number 1. Next, for the second student, they assigned the number 2. For the third, 3, like that. For 140th student, they assigned the number 140, just like that. Okay. Next, all even numbered students opted mathematics course. Means what? How can we find n of m? Tell me. N of m means number of even numbers from 1 to 140, like that. So how many even numbers are there? 1 minute. 1, 2, 3, 4. From 1 to 4, how many even numbers are there? 2, 4. 2 numbers are there. Similarly, how many odd numbers are there? 2. So therefore, 50-50%. Half of even numbers, half of odd numbers. Because the last number is even number. So therefore, the number of even numbers is equal to 70. Therefore, n of m equal to 70. Right? Did you understand? Next, those whose number is divisible by 3 opted physics. So how can we find n of p? Tell me. N of p means number of divisible by 3. Number of numbers which are divisible by 3. 1 minute. Actually, 1 to 140 is there. 140 means divided by 3. So 3 2 ja 6, 3 ja 9, 3 4 ja 12, 3 5 ja 50, 3 4 ja 12. So it remains 20. Next, 3 6 ja 18. Remainder is 2. So integer part is 46. Means how many numbers are there which are divisible by 3 from 1 to 40 means quotient 46. So therefore, n of p is equal to 46. Next, similarly, n of c is equal to n of c means what? Those whose number is divisible by 5. So number of numbers which are divisible by 5. That is equal to, divisible by 5 means just you divide by 5 and find the quotient only. This is the procedure. So 5 2s are 10, 40, 5 8s are 40. So remainder 0. So 28. So how many numbers are there? 28. Therefore, n of c, chemistry, that is equal to 28. Did you understand? Right. Next, we shall find n of m intersection p. N of m intersection p means what? Even numbers, next divisible by 3. So number of even numbers, comma, and which are divisible by 3. So total even numbers is 70 only. So 70 divisible by 3 means 3 2 ja 6, remainder 1 0, 3 3 ja 9. So remainder 1. Okay. What is the quotient? 23. So therefore it is 23. So out of 70 even numbers, how many numbers are there which are divisible by 3? 23 numbers are there. So therefore n of m intersection p is equal to 23. Next, n of p intersection c. N of p intersection c means what? Divisible by 3 and divisible by 5. The number of numbers which are divisible by 3 and not are, and divisible by 5 and divisible by 5, that is equal to that is number of number of numbers which are divisible by 15. LCM of 3, 5 is 15. So out of 140 numbers, it is enough to find which are divisible by 15. So the number of, it is enough to find the number of numbers which are divisible by 15. Means take 140 divided by 15. Find the quotient. Okay. Actually 15 9s are 135. So 15 10s are 150. So it is beyond, 150 means it is beyond 140. Therefore 15 9s are 135. The remainder is 5. So therefore quotient is 9. So how many numbers are there? 9. So therefore n of P and C, n of P intersection C is equal to 9. Later we have to find M intersection C. Next n of M intersection C, that is equal to M. M means what? Even numbers. C means what? Divisible by 5. So therefore number of even numbers which are divisible by 5. C means 5. Which are divisible by 5 is 1 minute. Even numbers, total 70 are there. So divisible by 5. Divisible by 5 means 5 1s are 5, 5 4s are. So how many are there? 14. So what I am telling that 70 divided by 5, then 14, remainder 0. Whatever it is, we have to take the quotient. Understand? 14. So therefore is 14. So therefore n of M intersection C, that is equal to 14. Understand? N of M intersection P intersection C. M intersection P intersection C means what? Number of M. M means even numbers divisible by 5 and 3. Number of even numbers which are divisible by 5 and 3. That is number of even numbers which are divisible by LCM of 5, 3 is what? 15. Divisible by 15. 15 is take even numbers. How many even numbers are there? 70. Find the number of numbers which are divisible by 15. Divisible by 15 means 15 4 ja 60. So 15 4 ja 60, remainder 10. Of course it is less than this divisor. Therefore remainder quotient is 4. So therefore is 4. Therefore n of M intersection P intersection C is equal to 4. Like that. Now we shall take the Venn diagram. You come here. So Venn diagram. So mu. So n of mu is equal total 140 students. Total 140 students. Next, maths, physics, chemistry. This is mathematics, physics, chemistry. MPC. Okay. What I said, first we have to fill this intersection part, this intersection part. This is 4. So this part is 4. This area is 4. Okay. Next MC14. MC14 means MC14. M intersection C means this area 14. Already 4 is filled. Therefore it is 10. Okay. This is over. This is over. PC9. PC9 means this area. This area is 9. Already 4 is over, so it is enough to fill 5. Next, MP23. MP means this area. So this area, MP, M intersection P. This area, 23. 23 means already 4 is filled, so therefore it is 19 MP. Okay. Next, N of C, it is 28. N of P, 46. It is 46. Next, N of M, it is 70. It is 70. Okay. Next, so total 70. Total 70 means 10, 20, 29, 33. 29, 30, 33. So 33 means 7, 40, 40, 130, 37. So this part is 37. Okay. Next, 19. Understand? Can fill like that 18, 9. Okay. Next. So what is the question? The number of students who did not opt for any of the 3 courses. Already I said this model. Who did not opt means this area. This area is what? We don't know. Let it be X. Say like that. Say like that. So therefore 37 plus 19 plus 4 plus 10 plus 18 plus 5 plus 9 plus some x equal to 140. So on simplification, x equal to 39. You can verify this. Hence the problem.